Good day, everyone. I am Denise Envalde Sancho from the University of Santo Tomas Faculty of Pharmacy, and I am going to discuss about repurposing antimicrobial agents of Coffea arabica as an anti-colorectal drug via in silico tools. Are you a regular coffee drinker? Well, as a student, I consume coffee every morning to start my day and to keep me awake. Basically, it's part of my routine to help me stay productive, especially while I study. Numerous studies have found the link between coffee drinking and colorectal cancer. And as you may be aware, cancer remains one of the major causes of death and morbidity in the Philippines, as well as a national health priority. However, epidemiologic data supporting this connection is still regarded as inconclusive. There were lingering questions about whether its specific components could either reduce or induce cancer growth. Furthermore, scientists advocate for a deeper understanding of coffee's constituents and mechanisms in order to strengthen the association between the variables mentioned. With a long term increase in coffee consumption in the country over the years, such concerns encouraged additional investigation into the components of coffee. Coffee is a beverage produced by brewing roasted beans from the plant genus Coffea, most notably Coffea arabica and Coffea canephora. It comprises a variety of physiologically active chemicals with antibacterial and anti-cancer activities. With the primary goal of repurposing antimicrobial agents to anti-cancer drugs, this study aimed to use in silico technologies to determine which bioactive components of Coffea arabica are potentially viable as anti-cancer drugs and to investigate whether these compounds could slow the growth of colorectal cancer. The abundance of online resources for investigating metabolite interactions with microorganisms of the human body cannot be understated. Three web servers, Way2Drug, AdmitLab 2.0, and Pacman were used to identify the most promising source of medicine derived from C. arabica that could suppress the proliferation of CRC cells. The bioactive components of C. arabica were first evaluated in order to determine which individual components have antibacterial and anti-cancer activities. Using in silico methods, a total of 15 compounds were screened and studied for their biological activities, physicochemical properties, medicinal chemistry, pharmacokinetics, and growth inhibition of colorectal cancer cells. Among the 15 starting metabolites, ferulic and picomaric acids were found to have the greatest potential for repurposing as anti-cancer drugs. They inhibited growth in colorectal cancer and colonic epithelial cell lines, which are possible colorectal cancer models. Cosmic ID 909748 was found to be the most sensitive to these metabolites, with half maximal inhibitory concentrations of 2.062184 logarithmic micromole for ferulic acid and 0.417473 logarithmic micromole for picomatic acid. CLDN4 and PPIA, two notable top genes with the greatest influence on cancer cell line sensitivity, were linked to the expression and prognosis of numerous cancer types, including colorectal cancer. Furthermore, ferulic and picomaric acids demonstrated good antimicrobial properties, particularly antiviral activities, as well as anti-cancer mechanisms such as membrane integrity agonist, anti-mutagenicity, and the JAK2 expression inhibitor for ferulic acid, which had a correlation with CRC tumor suppression growth as predicted by Way2Drug. Its pharmacokinetics and medicinal chemistry were also studied, and both showed high bioavailability, low metabolic rates, and excellent excretion from the body, indicating good oral drug candidates. In conclusion, only ferulic and picomaric acids remained promising candidates for repurposing their antimicrobial activity for anti-colorectal drug development. Pacman anticipated that these two compounds would exhibit exceptionally low half-maximal inhibitory values against a variety of colorectal cancer cell lines, implying that they could halt cancer progression. The most effective anti-cancer agent was picomatic acid, which had a potency of 0.41 to 1.81 logarithmic micromole, whereas ferulic acid had a potency of 2.06 to 3.69 logarithmic micromole. Thus, in vitro studies should be undertaken to determine the compound's possible hazards, effectiveness, administration, and mechanism of action.